So the terms having the same literal factors, right? If the literal factors are same, those terms are called like terms, right? Okay. For example, suppose we are having 5x square y, okay, and minus 10 by 3 yx square, right? So very first we will see like what are the literal factors, right? So now in this first term, 5x square y, what is the constant factor? 5 is the constant factor, yes or no? Getting that? Then x square and y, right? So among these, x square and y are the literal factors, yes or no? Okay. Now similarly, just see the another algebraic term, minus 10 by 3 yx square. So this 10 minus 10 by 3 is the constant factor, right? Whereas y and x square are literal factors, right? Okay. So there is a constant factor and literal factors. Now, how we will identify the terms are like? We will check the literal factors only, right? We will not check the constant factor. There is no relation with the constant factor for like and unlike terms, right? So what we will check? We will check the literal factors. Are they same or they are different? Are you getting it? So we have to find like are they same or different, right? So what are the literal factors here? Just see. Here we have x square. Everybody see to the board. Here we have x square. Here also we have x square. Here we have y. Here also we have y, right? So you can see in both the terms, the literal factors are same. X square, y, y. Getting it? X square, y, and y. Since they are same, these terms are said to be like terms. Okay, are everybody getting this? How we will identify this? Okay, so these are what kind of terms? These are like terms. Is it clear? Why? Because they are having same literal factors. Okay, now on the other hand, what are unlike terms? What are unlike terms? Now, what are unlike terms? In any algebraic expression, if the terms do not have same literal factors, then we call them unlike terms. Okay. So, if they are not having same literal factors, they are said to be unlike term. For example, consider these two algebraic terms, minus 5xy square and 10x square y. First, find out what are the factors. Constant factor is minus 5. Then we have x and y square, right? So these are the literal factors, right? Now, for the another algebraic term, 10 is the constant factor. Then x square and y. So here, these are the literal factors. Now, let's see, are they same or different? So just check it out. Here you have x. Everybody see to the bro. But here we have x square. Power should also be same. For the variable, means for the literal factor, their power is also important. They should be same. So here we have x, both sides we have x, but we have here x, but in the other term, we have x square. So their power is not same, right? So they are different. And similarly, if you see here, y square is another literal factor, but here we have only y. Is that clear? So since they are not having the same literal factor, right? Not same literal factors, right? That's the reason they are called unlike terms, right? However, they look like that they are similar, x, y, but the power of the variables are different, right? So they should have same power for the literal factors. Is that clear? So we will check the powers also, right? However, there is no relation with the constant factor. We do not check the constant factors. Okay, we only check the literal factors. If the literal factors are same, the algebraic terms are said to be like terms. If the literal factors are not same, then the algebraic terms are called unlike terms. Is that clear? Okay, it is exactly like that as you are studying in fractions, right? Unlike fraction and like fractions. Fractions having same denominator are like fractions. Having different denominators are unlike fractions. So similarly, same literal factors, like terms, like algebraic terms, if they have different literal factors, then the algebraic terms are said to be unlike algebraic terms. I hope you're getting this. Yes or no? Now, let's see how to find out whether the given terms are like or unlike. So look at this question. Check whether the given terms are like or unlike. The first part is 7x and 12y, right? So first, what we will do, we will find out the factors. So what are the factors of 7x? 7 and x. Getting it? Now, what are the factors of 12y? 12 and y. Is that clear? Right? Now look at the literal factors. What are the literal factors here? Here it is x, but here it is y. So literal factors are not same, right? They're not same. So they are unlike terms. What kind of terms they are? Unlike terms. We do not check the constant factor, right? Okay. We always check literal factor. If they are same, like terms. If they are not same, they are unlike terms. So here in this example, we are having different literal factors. So they are unlike terms. Now see the B part. 15x. Now, what are the factors of 15x? 15 and x. And for minus 21x, factors are minus 21 and x. So now, what is the literal factor here? It is x here, and here it is also x, right? So in this case, literal factors are same. Are you getting that? Literal factors are same. That is x. So what type of terms they are? They are like terms. Okay. So they are like terms. The B part, 15x and minus 21x are like terms. Why? Because they are having same literal factors. Is that clear? So now look at these two examples, other examples. Now for this one, C part, PQ square. Now what are the literal factor for this? P and Q square, right? Whereas the other term, minus 4PQ square, the literal factors are P and Q square, right? So if you can see here, P here, P here, that is same. Q square here, Q square here, that is same. So what we are having here? Same literal factors, including their powers, right? So power is also same. Here it is Q square, here it is Q square. Here the power of P is, which is not written, but it is 1. So here also we have 1, right? Okay, so we will check the exponent of the variable also. So since we have same literal factors, therefore they are like terms. Is that clear? They are like terms, right? Now look at the D1, 6xy square, right? So what are the literal factors? X and y square. Now for the other one, minus 9xy square, x square y. What are the literal factors? X square and y. Now let's check whether they are same or not. So here it is x, but here it is x square, right? So they are not same. Their exponent is different. Now here y square, but here we have y only. So this is also not same, right? So since they do not have same literal factors, right? Literal factors are not same. Okay. So what kind of terms they are? They are unlike terms. So in this way, we can decide whether the given terms are like or unlike terms. I hope now you're getting it. Now, look at the another question. Identify like terms in the following. Okay, so there are some terms you can see here, right? Okay, now you have to identify the like terms from these given algebraic terms. Okay, so what we will check? We will check the literal factors. Is it clear? Right? And we will write them, which are the like terms. Okay, so now look at here. Minus xy square. Right? So what are the literal factors? X and y square. Now check if there is any other xy square. Yes.
2xy square.
2xy square. Right? Do not see the constant factor. Only check the literal factor. Xy square, xy square. Very same. Okay. So these are like terms, right? So just write down like terms. Minus xy square, 2xy square. Okay. Now we can find another set of like terms. Okay. So now check it. Minus 4yx square. Minus 4yx square. Is there any other yx square?
Ma'am, x square y. 20x
Yes.
square y.
20x square y is the same thing, right? So whether you write x square first or y first, right? It is same thing, right? Why? Because we know that multiplication is associative. It is commutative, right? You can change the order of the numbers, right? So a into b can be written as b into a, right? Similarly, y into x square can be written as x square into y. That are same. Is it clear? Okay. So in this way, we can see here that terms, the literal factors are same. Y, x square, right? So these are like terms. So write down like terms. Minus 4yx square and 20x square y. Now find out another set of like terms. Now look at here, 8x square. Is there any other x square term?
Minus 11x square.
Minus 11x square, right? So this is also x square term. Is that clear? Okay. So again, these are the like terms. Like terms are 8x square and minus 11x square. Okay. Now let's see if there is any other set of like terms. Okay. Now come to the next one. We are here. We are having here 7y. So literal factor is y here. So is there any other y here? Any other y term? No. We don't have any other y term. Yes or no? Right? So we can leave this. Okay, because we do not have any other y term. Then minus 100x. Is there any x term here? No, we do not have, right? Here we have y and x, right? So these three terms are, we do not have any set of, like terms with along with this, right? So these are all unlike terms, right? So you can write down unlike terms, right? 7y minus 100x and minus 11yx, right? So these are all unlike terms. Is that clear? So in this way, we can identify which are like terms and which are unlike terms within the given expression or within the given set of algebraic terms. So I hope you have understood this.